In this video, I'm going to be explaining the Net Change Theorem, which essentially is just a play on the fundamental theorem of calculus. So what it's really saying is that if you take an integral of a rate of change, and then you get the amount of change, or the amount that that function changed. In notation, it would look like this. So if I integrate a derivative or a rate of change, I get back to the original function, and I'm going to evaluate it at the top or the upper limit and subtract it from evaluating it at the bottom limit or the lower limit. This comes into play a lot with word problems. So that's essentially what we're going to be doing in this video, is interpreting rates of change or applications here. So in this first example, if the rate of change of a baby's growth measured in pounds per week is represented by this, then what does this represent? Well, this represents the integral of the rate of change. So it'll be the amount of change of whatever we're changing. So go back and look at what we're changing in. We're changing the baby's growth, or essentially the weight. So this would represent the weight change, or the amount of change in pounds of the baby's weight from when it was born to 2 weeks, or the end of 2 weeks. So essentially the baby's weight as it changed in the first 2 weeks of its life. And we could evaluate that if we knew any more data about this problem. So if we knew the baby's weight at the end of 2 weeks and we knew the baby's weight at birth, then we could find the amount of change in that baby's weight in those 2 weeks. Let's look at another. This time we're talking about an oil leak. If an oil is, or a tank of oil is leaking at a given rate, represented by this function, R of t, and it's measured in gallons per minute, then what does this represent? So this is our rate of change of gallons per minute, or how fast it's leaking. And it's represented from the time at the start of the leak to 120 minutes later. We're being measured in minutes for our time there. So this would represent the amount of oil that leaked, or the amount of gallons of oil that leaked during those 120 minutes. So from the initial time it started leaking to at the end of 120 minutes, and that would be the amount of oil in gallons that leaked out of the tank. We could also look at this in a slightly different way. We could look at the volume of the tank and say, well, this is representing the amount of change in our volume, and our rate of change is leaking or decreasing. So we know that we have a negative rate of change. So we could call R of t capital V apostrophe of t, representing the rate of change of the volume. And if we make it negative, we know it's decreasing. So then we could look at the problem this way. So we could integrate our rate of change of volume by saying, well, what is the volume at 120 minutes minus the volume at the start of the leak? If we make that the opposite, because our rate of change is negative, then we just flip these two numbers, and we could find out the volume after 120 minutes. So a couple of different ways that we can interpret that. But either way, we're representing the amount of change in the tank, or the amount of change of the volume, or the oil that was leaked out. One more time, let's go at it from a different angle. We're told that a honeybee population starts with 125 bees, and its population is increasing at a rate represented by this. And it's increasing at a rate of bees per week. So this time, let's write a definite integral that represents this information, and then show how we would evaluate it. So if we're starting with an initial population of 125, then that is in addition to all of the bees that are added after that. So our integral is representing the number of bees that have increased in our population after 10 weeks. So starting at our 0 time and going up to 10 weeks and integrating our rate of change in the population would give us the total population. And we're just going to add that initial population to it, and that would give us our total population after 10 weeks. To evaluate it, we could integrate the derivative or integrate the rate of change. So the number of bees after 10 weeks minus the number of bees that we started with, plus that initial population of 125. So that's essentially the net change theorem. If we integrate a rate of change, we get the total amount of change of whatever we're talking about.